Hey y'all, it's me, Miss B, and today we are talking about the ellipse, which is the first part of our conic section. So we're not covering a circle, but a circle comes from if you take a cone and you cut it, slice it straight across. If you were to slice it at an angle, however, that went through both sides, then you would end up with an ellipse. Sorry, it's a little bit squiggly of a line there. Okay, so let's go ahead and talk about the parts of an ellipse. The first is going to be A, which is the distance from the center to the vertex, or a vertex. So that distance is right, excuse me, here. B is the distance from the center to the co-vertices, or co-vertex. So that is going to be, oh wait, I think I labeled that wrong. Sorry, this blue line should go from here to here. That's my bad. And then purple will go from here to here. And then C in the orange is the distance from the center to the focus. So that is going to be this distance right here. And so there's a little bit of overlap there. Okay, the major axis, so what each of these are is going to be half of that distance. So the length of the major axis is going to be 2A. The length of the minor axis is going to be 2B, and then the center is labeled as HK. And our major axis is always the longer one. All right, so if we have a horizontal major axis, so it's more oblong like this, then we're going to follow the equation x minus h squared over a squared plus y minus k squared over b squared equals 1. And it's always going to be equal to 1. And A is always going to correspond with the major axis as well. So our vertices are going to be H plus or minus A, K, and our foci are going to be H plus or minus C, K. If you want to write the equation for the co-vertices, that's going to be H, K plus or minus B. All right, if we have a vertical major axis, that's going to be x minus h squared over b squared plus y minus k squared over a squared equals 1. So it's equal to 1, but our a squared goes with y, and so it's longer this way. Our vertices would then be h, k plus or minus a, and the foci would be h, k plus or minus c, and the co-vertices are h plus or minus b, k. All right, and then this note says that A is always larger than B. All right, so let's go ahead and graph. All right, so I always start by finding the center, the vertices, and the foci, and then graphing after. So first to start, you'll notice that I have minus up here, so I'm going to go ahead and rewrite these so I have minus in my numerator. So this is x minus 2 squared over, and I'm going to go ahead and write this as 3 squared plus y minus negative 1 squared over 5 squared equals 1. So I'm writing this because that's going to get me to my a and b, because this is going to be my b squared and this is going to be my a squared. And this one's a squared because 5 is bigger than 3. Okay, so then my center is HK, so that's going to be H and K. So positive 2 and negative 1. The vertices, so that's going to be, since we have a major vertical axis, it's going to be H, K plus or minus A. So my H is just 2, but my K plus, so we're looking at, so negative 1 plus 5 is 4, and negative 1 minus 5 is negative 6. So this is 2, negative 1 plus or minus 5 here for that H plus or minus Ka. Make that a little bit more clear. All right. My covertices, so that is going to be 2 plus or minus b, which is 3, k, which is negative 1. So I have 5, negative 1, and negative 1, negative 1. Okay, and then finding the foci is a little bit more involved, so I have to find c first. So c squared is equal to a squared minus b squared. A squared is 25. B squared is 9. So c squared is equal to 16, making c equal to 4. So that means that my foci are going to be 2, negative 1 plus or minus 4. So we've got 2, negative 5, and 2, 3. All right, and then we'll plot all those points. So the center, 2, negative 1, 2, 4, 2, 4, and 2, negative 6. Off by 1 today. Then we've got 5, negative 1, negative 1, negative 1. And then finally my foci are 2, negative 5, and 2, 3. I'm going to draw my ellipse here. Mine's a little fancier, so I can draw mine a little nicer than you. Alright. That's probably good. Okay, so as you can see, that is drawn that way. Okay, let's do another one here. So, rewriting here, just so I have it, it's going to be x minus negative 3 squared over 4 squared plus y minus 1 squared over 2 squared equals 1. So my center is negative 3, 1. My a squared is 4 squared, and my b squared is 2 squared. So a is 4 and b is 2. So my vertices are going to, making sure I did these ones right, yeah. Okay, so my vertices are going to be negative 3 plus or minus 4. So that's going to be, and then 1 is going to be my y value for those. So negative 3 plus 4 is 1, and negative 3 minus 4 is negative 7. Covertices, so my x value is the same. My y value, I'm adding and subtracting 2, so 1 plus or minus 2. So 1 minus 2 is negative 1, and 1 plus 2 is 3. To find the foci, I'm doing c squared equals a squared minus b squared. A squared is 16, b squared is 4. Nope, that's not right. So c squared is equal to 12, making c the square root of 12, which the square root of 12 is about 3.5. And we will round so that we can graph easier. All right, so let's go ahead and graph those points. Negative 3, 1, 1, 1, negative, oh, that's not the right one, 1, 1, negative 7, 1. You can see that these are 4 spaces away from each other, just like 4 there. Okay, for the covertices, I'm going up 2 and down 2, since b is 2. My foci are 3.5 away and 3.5 away. So when I draw, there is my graph of that function. Okay. So sometimes it can be as easy as that. Sometimes it's going to give us the stuff and we have to fill in everything. We have to find the equation. So it says find the standard form of the equation of the ellipse with the center at the origin, foci plus or minus 6, 0, and minor axis length of 8. So I like to plot the information first. So my origin is at 0, 0. Both centers at the origin. My foci, I was using purple before, so I'm going to go back to that just so we can kind of stay on the same page here with color coordinating. My foci, so that was in red before, is at plus or minus 6, 0. So we've got 6, 0 and negative 6, 0. And then the minor axis length, which I had in blue, is 8. So the whole thing is going to be 8. So then top down is going to be 4 and 4 because it splits down the middle. So this whole thing is equal to 8. Okay. So we need to find H, we need K, we need A, and B. right, so I have h and k because it was given to me. That's the 0, 0. My b I was also able to find. That's the 4. Now, in order to find a, I'm going to have to use c squared equals a squared minus b squared. So my c squared, so c is equal to 6. So 6 squared is equal to a squared minus b squared. B is equal to 4. So I have 36 is equal to a squared minus 16. Add 16 to both sides. 52 is equal to a squared. And that's really what I need right there, is a squared. Because when I plug it, I wrote too big here, but when I plug it back into my equation, that x minus h squared over, and we do have this major axis here, plus y minus k squared over b squared equals 1. I have a squared, so there's a squared there and a squared there. So x minus h, so x minus 0 squared over 52 plus y minus 0 squared over b squared, which is 16, equals 1. And we'll go ahead and leave our answer just like so. So that is the equation, standard form of the ellipse. All right, skip this one, leave it for class. It's very similar. All right, this one says, write the equation in standard form, identify center, vertices, and foci. So we are completing the square on this one. It's a little weird, but it's kind of fun to do just because we get to think pretty hard. Okay, so what we're gonna do is we are going to group these. I'm gonna leave this in a group and this in a group. So I have x squared plus 4x plus something and plus 3y squared plus 12y plus something equals 11. Okay, now I want my answer to be as x minus h squared over a squared plus y minus k squared over b squared equal to 1. So I need something squared. So I am going to complete the square here to do this problem. In order to do that, I'm going to take my b value and divide it by 2. So I'm going to take this number, divide it by 2, and square it. Let me write this in a different color here. So take this number, divide it by 2, and square it. So 2 squared is 4, and that number is going to go in right here. Okay, for this one, I actually need to factor it first. So I have 3y squared plus 4y plus something. So I'm going to take this number, divide it by 2, and square it. That gives me 4. But when I do 3 times 4, that's equal to 12, which is what I'm putting in here. So I'm multiplying, the 3 and the 4 together to get that 12. Okay, but if I add it to this side, I also need to add it to the other side over here. So plus 4 and plus 12 on the right side there. I'm going to take this big old equation, which I just kind of muddied up, and I'm going to rewrite it down here. So I have x squared plus 4x plus 4 plus 3 times y squared plus 4y plus 4 equals 11 plus 4 plus 12, which is 27. Okay, so then I'm going to factor. So this is a perfect square trinomial. So this is x plus 2 squared. And this one is y plus 2 squared equal to 27. And then if I divide everything by 27, then I get x plus 2 squared over 27 plus y plus 2 squared over 3 over 27 is 1/9 equals 1. And so now it is in the standard form. The center is -2, -2. Let's go ahead and write out what A, B, and C are. So A is the square root of 27, which is about 5.2. B is the square root of 9, which is 3. And C is equal to the square root of 27 minus 9, which is equal to 4. Okay, so vertices are going to be -2 plus or minus 5.2. So -3.2, -2, and positive 7.2, -2. Just running through this pretty quickly. Co-vertices are going to be -2 and -2, but we're adding and subtracting 3, so that's 1 and -5. And then the foci are going to be -2 plus or minus 4, -2. So we get -6, -2, and 2, -2. All right, that's all.